So we are looking at simplifying radical expressions day 2. So how do you simplify variables in the radical? How? Well, radicals and variables are kind of like multiplying and dividing were back in the day. If it is an odd variable, then it is going to stay under the radical. If you have an even, then you are going to divide that even number by 2. Now, we also have a rule called the even, odd. And when you have an even, and then an odd, it also sort of changes how or what we look at. Okay. So how do you simplify a radical? We simplify it by looking at the variable. So the square root of x squared is always equal to the absolute value of x. And we're going to talk about that even, odd rule and why there's an absolute value. Remember, I told you all odds are going to be left with a square root. So cubed is odd, so you're left with a square root. 4 is even, so you divide it by 2 and you get x squared. 5 is odd, so you take the one odd, you make it here, and then you take the even number below it and divide it by 2. X to the 6th, 6 divided by 2 is 3, so you take the even, divide it by 2, you get 3. When you take an even number and you divide it by 2, and that number becomes odd, then you need absolute values. So again, if you look at these in general, if you have an odd exponent, you have a square root. Even exponents will get rid of the square root. So just something to kind of write down, put in the side, give yourself it as a mini note. So as a general rule, what we do is divide the exponent by 2, and the remainder stays in the radical. As a general rule, what we do is divide the exponent by 2, and the remainder stays in the radical. So to simplify x to the 7th, you're going to take that rule and apply it. So x to the 7th is the same as x to the 6th with an odd over here. So you take the even, divide it by 2, and the odd stays. So when you have an odd number, you always look for the even, one less than that number, divide that even by 2, and keep one under the radical. And then the last rule is that if you have an even exponent under the radical, an even exponent to start under the radical, and when you divide that even number by 2, you get an odd number, then you need to put absolute values around the variable. The reason for that is because all square roots are positive. If you have a square root to an even power, it has to stay positive. Well, if you take it and you simplify it to an odd power could become negative. That's why we need the absolute values. So jumping down, simplifying a number, that's what we did previously. So the square root of 12, you want to break it into a perfect square and then its remaining numbers. So 12 gets broken into 4 and 3. The square root of 4 is 2. 2 square roots of 3 is our simplified answer. So now we're going to take numbers and combine them with variables. So the square root of 48, you want to break it down into a perfect square. So 48 divides by perfect square 16. So you get 16 and 3, so that breaks down your 48. 6 is even. So the rule of thumb is the square root goes away and you divide your even by 2. So you get x cubed. But this was even. That is odd. Therefore, my variable needs absolute values. The square root of 16 is a perfect square. 16 as a perfect square becomes 4. So we get 4, absolute value of x cubed times the square root of 3. Okay, the square root of 400. So you want to break 400, if you don't know, into two perfect squares. 400 itself is actually a perfect square, but if you didn't recognize that, maybe you broke it into 4 and 100, and then you would recognize that those are both perfect squares, and you would simplify from there. So square root of 4 is 2. Square root of 100 is 10. So you find out that the square root of 400 is actually 20. The square root of x squared, the rule is you take the square, divide it by 2. So you get 1. But this is even, that is odd. So it's 20, absolute value, x. Number 4, we have 20 square rooted and x to the 5th. So you want to break 20 into a perfect square, and x to the 5th breaks into an even and then one singular odd. A perfect square that goes into 20 is 4. So you get square root 4, square root 5, because 4 times 5 is 20. X to the 4th times x is the same as x to the 5th. So then you clean up your perfect squares, which are 4 and x to the 4th. So you get 2x squared. And that leaves 5x. What's nice is a lot of times numbers repeat themselves. We already did 48. We know it's 16 and 3. 2 variables doesn't change the rule. So it's still like looking at the square root of x squared and the square root of y to the 4th. So we treat them as individual parts. So the square root of 16 is 4. The square root of x squared is the absolute value of x because it's even but becomes odd. Y to the 4th becomes y squared. That's even and this is even, so no absolute value needed. And then the square root of 3 doesn't simplify, so it tags along. Yes? No, because multiplication is commutative, so the order with which you simplify doesn't matter. Eight breaks into 4 and 2. 25 would become 24 and x. So the square root of 4 is 2. Square root of 24 is 24 divided by 2, so 12. And then your 2 and your x have no friends, so they stay in the radical together. They're lonely. Okay, 9 is a perfect square, so the square root of 9 is 36, even or odd? So what do we do with an even number? Divide by 2. So what is 36 divided by 2? 18. Is 18 even or odd? 18 is even, therefore no absolute values. So the square root of 9x to the 36 will give you the same answer as 3x to the 18. So if you plugged a number in for x, so like let's say x equals 3, and you plug that in under the radical versus into your answer here, you should get the same answer for both. So it's like 1,162,261,467. And again, you could type that in and do 9 times 3 to the 36th power, and you should get the same value, which we can see that we do. So 3 to the 18 times 3, the square root of 9, 3 to the 36. Same answer. What? Okay, and the last one. So 3 variables, still doesn't change the problem. The square root of 6, does it divide by a perfect square? No, so it's going to stay the square root of 6. X cubed, even or odd? Odd, so that means 1 comes out and 1 stays in. Because x cubed is kind of like x squared times x. So the square root of x squared becomes x. Is x to the even or odd power? Odd, because x to the 1 is odd. So you have x Why doesn't this x need absolute values? Because it didn't start as an even number. Okay, y to the 6th, even or odd? So we take that 6 and we divide it by 2. So 6 divided by 2 is? Alright, so we get y cubed. It started even, it became odd, therefore we need absolute values. Okay, z to the 9th, even or odd? Odd, so it's kind of like z8 and z. So you know that a z is going to be underneath to n. What's 8 divided by 2? So 4 come out, 1 stays in. Questions, comments, concerns? So if I picked on each of you, would you be able to do these? So your homework is that next page in the packet. You're doing 1 to 30 because you have 20 some plus minutes in class to work on these, and I know that they're a challenge. So again, you can ask me questions, you can, work independently. You're taking the number underneath, you're trying to find a perfect square that divides into it, guys. You're trying to take these numbers and divide them by perfect squares, not just random numbers, but by perfect squares. So that's why in the front of this packet, your bell ringer on day 1 was to write down the perfect squares. What perfect square goes into 125? 25. What perfect square goes into 216? Hint, it's the one after 25.
26.
Not the number after. 36. The perfect square after. Sorry. Okay, so on and so forth. 512 also divides by a perfect square. Bigger than 4. 23 is not a perfect square. What? 5 is not a perfect square. Yeah, the next perfect square bigger than 4 is 9. It's on the front of your packets.